So hello grade 7 learners, welcome to our mathematics lessons. So for today, we'll cover an important components in numbers in algebra. This includes roots, rational numbers, sets, integers, operations, expressions, and absolute values. So get ready with your notebooks and let's learn. So let's begin to the square roots, cube roots, and irrational numbers. An square root is a number that when multiplied by itself, it gives the original number. For example, the square root of 36, it is equal to 6 because when you multiply 6 times 6, it is equal to 36. Another example, the square root of 25, it is equal to 5. So this is called the perfect squares. So we also have the cube root. It is a number that when you use 3 times in a multiplication, it gives the original number. For example, the cube root of 64, it is equal to 4 because when you multiply 4 times 4 times 4, it is equal to 34. Another example is the cube root of 8. It is equal to 2. So this is called the perfect cubes. So as you can see in the table, you have the perfect squares and the perfect cubes. So let's move on to irrationals. So there are numbers that cannot be written as fraction and their decimal form. So this is called the irrational numbers, like the pi, square root of 2, square root of 5, square root of 10, and the square root of 3. So this is because there is no exact fraction for this. So let's move on to the sets, subsets, union, and intersection using Venn diagram. So when we say set, it's a collection of objects or numbers. For example, in the set A, we have the 1, 2, and 3. A subset is a set that contains sums or all elements of another set. So let's have this example. For example, we have the set A and the set B. The set B have the 1 and 2 elements. So the subset is B is subset of A because the B is inside the A. The union of two sets combines all elements from both sets. The intersection of two sets is what they have in common. So let's have this for better understanding. So this is the union. A union B, which means elements that belong to either A or B or both. This one is called the A intersect B. It means that elements that belong to both A and both B. So let's move on to the subsets of real numbers. These big sets has several subsets. We have the natural numbers, which is the 1, 2, 3, and so on. The whole numbers from 0 and so on. The integers, which is the from negative 0 then positive. Rational numbers are any numbers that can be written as a fraction like 1/2 or -3. So and the irrational numbers, like I said before, the numbers like pi or square root 2 that can be written as fractions. So this is the illustration of the real number system. As you can see, the real numbers, irrational numbers, rational numbers, integers, whole numbers, and the natural numbers. So let's move on to the 4 operations with integers. So in addition, same signs add and keep the sign. Different signs subtract and keep the sign of the bigger number. For example, we have -3 plus 2 plus -2 is equal to -5 because it says same signs, add and keep the sign, which means we have the negative 3 plus negative 2, it is same negative, so we add that and keep the signs of both negative. Let's try another example. Let's say we have the negative 5 plus 2, it is equal to negative 2. It says because different signs, subtract and keep the sign of the bigger numbers. So the bigger number here is the negative 5, which means we will copy its sign. We have the multiplication, division. So in this operation, same sign positive, different signs negative. For example, we have negative 4 times negative 2. It is equal to 8. Why? Because it is same negative, which means in this rule, same signs is equal to positive. Let's try another. Let's say we have negative 4 divided by 2. So it is equal to negative 2. So because its rule is different signs negative. So negative 4 divided 2 is equal to negative 2. So let's move on to the simplifying numerical expressions with integers. So if you're familiar with PEMDAS, it is an acronym for P, it is parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. So let's have an example. So let's say simplify 3 plus negative 2 times 4. So in the role of PEMDAS, we first solve these two. So negative 2 times 4 is equal to negative 8. Then add 3 plus negative 8, it is equal to negative 5. So that's how we solve using the PEMDAS. Let's have another example. So let's say we have 5 minus 2 square plus 6. So we first need to solve the parentheses. So 5 minus 2, it is equal to 3 plus 6. Then 9, 3 times 3 is equal to 9 plus 6, it is equal to 15. So that's how we solve the equations using the PEMDAS. So practice is the key to master this. So let's move on to the absolute value of an integer. It is distance from 0 on the number line, regardless of directions. Absolute value is always positive because distance can't be negative. So for example, we have the 5. In absolute value, it has the 2 lines like parallel. 5 is equal to 5. Even if it is negative, it is also equal to 5. because the rule of absolute value is that it always positive. So that's all for our class today. So I hope you learn po.